Good afternoon, everybody. My name is Nico Katsanis. I am a human geneticist, and what I would like to do for the next time is tell you a little bit about something that is both my passion, but also that something else that we also need to start thinking about that perhaps we have not done as good a job at articulating to people. So, of course, we're talking about climate change, we're talking about data protection, all these things. So perhaps some people will think that what I'm about to tell you is very small. But I would argue with passion that what I'm trying to tell you is also very, very important. And of course, that is the concept of rare genetic diseases. And I think for many, many years, we've lost out of the gate because we said, oh, rare genetic disease. It can't be that important. But let me give you a little bit of a sense of what this is. So if I were to tell you cancer, you'd say, oh, that's very important. Well, I can argue with some merit that cancer is about 2,500 rare diseases all put together, because the cancer of the liver is very different from the cancer of the pancreas. These are data that we have from the United States. There's at least 10,000 rare genetic diseases, and we don't know what the edge of rare genetic diseases is. They affect about 30 million people in the United States, and we know that they affect at least 400 million people on the planet. I can assure you that this is probably an underestimate because there are parts of the world where we haven't really been able to measure this. So the other thing we're talking about, if I can make, is I want to highlight a few of the areas that we actually now have the technology to do something about, and we are doing something about. So amid the doom and gloom of our planet and everything, there are some things that are happening. Until a few years ago, certainly before the Genome Project produced the first iteration of the map of the human genome, it took many, many years for patients and their families to get a molecular diagnosis for their disease. And one thing I would like you to remember is that especially in the rare disease space, the patient is not only the patient. The patient is the parents, individuals who carry enormous responsibility and guilt about what is happening to the child. The patient is the brother or the sister who will also be called to provide care for the child because these individuals will grow up. And the patient is also the entire family and all the complexity that comes with that. So we have a responsibility, I would argue, to intervene to the best of our ability. On average, it takes 5 to 7 years to get a molecular diagnosis for a rare genetic disease. And depending on where you are in the world, that time can be different, and also the cost can be anywhere from very low, if you're in a public healthcare system, to very, very high. Talking about costs, one of the things that we have seen in the last few years is finally we're beginning to get drugs. Until about 10 or 15 years ago, for many, many rare genetic diseases, it was a death sentence for the child and emotionally for the family. I can tell you divorce rates among families that care for children with rare disease are extraordinarily high because of the stress. But let me talk to you very briefly. This is spinal muscular atrophy. In one iteration of the disease, children will be dead by the time they're 1 year old. However, in the last 2 years, we have seen 2 amazing drugs that I'm showing you here, and both are very, very effective at protecting these children and giving them at least an opportunity for a better life. However, the cost of these drugs are the things of nightmares. The oligonucleotide for Spinraza, the Biogen product, is $750,000 for the first year, $350,000 for every year for the individual's life. The other project, which is a gene therapy product, it's a single shot of $1.9 million. Now, it is very, very easy to vilify the pharmaceutical industry and say, greed. And that is also partially true. But the other thing that is true is that we have failed to generate the right economic conditions to change this equation. I will speak a little bit about this. And the last thing I want to talk to you about is the notion that as we start talking about data, I would also like us to add to this equation the idea that we need to start thinking more about what we're going to do with genetic data. because genetic data will in time become almost as valuable as people's national identity numbers, social security card numbers, and this and that, because they will carry more and more predictive information about who you are, what jobs you might be best at, what healthcare needs you might have. And at the moment, it is quite not clear who owns the data. We are making progress, but it is up to the next generation of thinkers to actually help us understand this. So some people will argue, okay, rare genetic disease, you told us a nice story, but at the end of the day, who cares? I mean, the planet is warming up, the seas are rising, all this. Well, I think we should care because it's a massive stealth problem in healthcare that is going to hit in all corners of the population, especially in parts of the world that have a very high degree of consanguinity, that is to say, first cousin marriages. And if you don't think that matters, I remind you that these parts of the world also represent about 25 to 30% of the entire human population. So this will become a global problem. In 2004, where we have data from, we know that 71% of children admitted had a genetic disease, and you can see the numbers. I assure you, the numbers are a lot bigger. But there's another point that I really want to make that I think that goes to the spirit of what we talk about. In 2001, the international community came together in this extraordinary effort that to me is very similar to when we went to the moon. I was very fortunate to be there to witness it. And it was a time for us to celebrate. And I celebrated and I cried when this thing came out. But then we must make sure, somebody earlier today spoke about trust. The other thing we promise people is that by having the human genome, we will be able to improve the human condition and healthcare. And as I stand before you today, I'll tell you that we're trying, but we haven't done well enough. We're not doing good enough. We have to do much, much better. And in order to do much better, we have to move both our emotional needle, but also the economic model. So in our work, the little drop that we try to use in the bucket is small, but I think the method by which we have gone about it is helpful and informative. Many years ago, we started something that is called the Task Force for Neonatal Genomics. Our goal is to become irrelevant. And what I mean by this is to solve the problem so that we do not want to exist. I don't want to have job security out of this. What we did learn, though, is that the only way to approach the genetics of rare genetic disorders is to actually bring together many stakeholders to revolve around the patient. You must have very good clinical workup for patients with rare genetic disease, because oftentimes the problems that they struggle with are affecting multiple organ systems, and you need to be able to capture this data in a reasonable way. You must, of course, have genomics, and this is an area that many of you will have known and you will have read have made extraordinary progress. The cost of sequencing a genome is now under $1,000 in the United States and is continuing to drop. But we also need to have ethics in biology. And unfortunately, we won't be able to compute our way out of this problem. For some parts of this, computational solutions will provide the answer, no question. But we have to maintain biology. And one of the threats that I see is that we're shying away from biology that is difficult, and we're relying more and more on computation. And for some of this stuff, this is not going to work. In our own very, very small types of studies, we were able to recruit about 75 to 100 families per year, and they really add up. We identify about 10 new disease genes per year, and we have expansions. But the key thing is, among the community, we are observing a change in the narrative. We can now accomplish a diagnosis for a rare genetic disease in weeks to months. Remember the number I told you, years. Now, I happen to think that we can do even better, because I have the sense that if we actually build the right political willingness, we should be able to do this in the at the first sign of disease, which in many, many cases is the onset of life, as you choose to define it. And I think we need to move in this direction. The last thing I want to talk about is really the idea that we have to improve access and cost to drugs. Because I perceive a secondary threat, which is I will sit here and many other talented scientists and everybody in the community will do amazing things. But what is the point of doing all this if we do not offer this access to people around the world? I choose not to live in a world where only the ultra-wealthy remain healthy. But how are we going to do this? Well, There are sometimes all you have to do is wait. A lot of this is driven by patent law, and most patents will expire 17 years later. Now, to me, and to many of you, 70 years is a very, very long time. But under the lens of history, 70 years is just a little nothing. At the same time, I choose to believe that we have the opportunity to intervene so we don't have to wait. So one of the ways that I've been thinking about intervention is essentially something that I learned a little while ago. And it sounds a little bit difficult to say, but here it goes. Goodwill, positive emotion, and willingness to do have never really changed the world. Sorry. It hasn't. And I stand in front of everybody here telling you this to you as an absolute idealist. Idealism is a wonderful thing. Sometimes it works, but if you really want to change the world, you have to figure out what the market economics are going to be. This is true, at least in the Western civilization, from the time of the Roman Empire onwards. So I think I invite, especially I see many young people here in the audience, I invite you to dream. Please, dream. But keep one foot on the surface and make sure that you find the right practical tools for your dreams to become a reality. In our particular case, we think that we can use a free market economics model to improve the cost and the access to drugs from genetic discoveries. And the reason is this. One of the main reasons why this is so high is, one, because it costs a lot of money to bring a drug to market. And the second reason is that each drug represents a monopoly. If there's only one drug for the catastrophic disorder of your child, you do not have a choice. Is either the child dies or you pay $2 million. There is no choice number 3. So what we're thinking about is we want to change the equation. And our idea is to start treating diseases essentially like an investment portfolio. There's very, very good data, market economic data, that will tell you that if you distribute the risk of innovation, then you'll make money. I don't care about that, but others do, the people who sign the checks, and you're more likely to discover. And I know this sounds like a little bit abstract, so I'll give you a very tangible example that is happening in my lab right now. And by the way, if my lab is watching, I hope you're working. So this is degeneration of the photoreceptors. The image that you see on the side is the back of your eye, and all the darkened stuff is areas where cells have died and you're losing vision, and you can see on the depiction here what vision looks like for an individual like this. So the situation is that we have at least 150 genes, probably more now, that cause retinal degeneration. The traditional paradigm is talented investigator, talented group, work on one gene, one protein, one pathway, one drug. Well, I think that's great, and I celebrate and I champion and I clap every time these people make progress. However, this is not an efficient market dynamics, because it means we're placing very high bets one at a time, and every time we lose a bet, we become a little bit more cynical and a little bit more resistant and a little bit more risk averse. Wouldn't it be cool, and this is not just fantasy, we are doing this, to actually start aggregating many, many genes for disorders and start developing drugs? So what we're doing in the laboratory right now is we're building tools to do drug discovery for genes in 50s and the 100s and 150s. And I'm sure as our technology develops better, we will also learn how to do a better job and scale this up. Because we can tolerate many winners. And the big idea is, as soon as we do this for the retina, and as soon as we miniaturize the effort, then we can start thinking about grouping disorders based on organs and cells. So in my mind, and in my dream, so my dream is to cure all rare disease. But because I have to be practical, I'm thinking that we need to have an economic model that will actually work to enable us to chase that dream. Because I got to go back. I was a student, I was a postdoc when this paper came out. And I am one of the many, many people who promised this little girl that I will make her feel better. And I cannot look at myself in the mirror until I do so. So please, let's figure out how to do this so they can all sleep better. Thank you.